Hello, this is John from the Magicians, and I'm here to go over the LEGO Mindstorms EV3 programming. So, let's dig in. Alright, so what you're looking at now is how that they have adapted and developed the programming for us to be able to do it a little bit easier than line logic and copy and pasting and Notepad and that sort of thing. So these different blocks represent, obviously you can go through motors, movement, display, sound, events, control, sensors, and then you have operators and variables, which are a little bit more complicated. But I am going to show you today what we did to program our bot, and hopefully this might be insightful for technicians and engineers of the present and future. So this one here, as you can see, is testing, and I also used it to calibrate the machine before deploying it, because in travel sometimes you might skip a tooth on a gear or something like that, or shakes around, so you have to recalibrate it. So this is actually the firing sequence, and I can test that before deploying. And then over here I have a couple of things where we can get it back tuned to where it's supposed to be before the firing sequence. That way it doesn't just crash into itself or break its knee or something like that. And then I have some movements over here. So I'm going to get more specific with these over here. This is what we have done. So the color tile reactions that you may have seen, this is how we built those and just kind of let them float. And so I guess let's start with this. This is basically a start button right here. So when the program starts, that's when you hit this button here, it'll start the program. I have this set to broadcast the go. Okay, so when it broadcasts the go, this triggers this loop over here. Okay, and these are just floating. Like as soon as the program starts up, these just happen right here. But okay, so I'll go back over here. So when it broadcasts go, I go into this navigation loop here. So it sets the movement speed and which motors are going to be my movement. You can see over here the colors match here to movement. So it's kind of a little bit easier to work with instead of copy paste, a bunch of black and white stuff. And then so here's the loop. So I have it going if the camera sensor detects black, then it stops moving. I have a little orange pulse there, waits 0.3 seconds, moves backwards for 0.5 seconds, waits at 0.2 seconds, and then now this move right 100 is actually a turn. So the 100 right or left is turning to the right or the left. So I have that turning for 1.25 rotations of the motor at 33% speed, so that way it doesn't throw itself down. So that's what it does when it runs into black. And then in this loop, it have it or else go straight. See what I'm saying? So unless it runs into that black, it's going to go straight. Now I have this these ultrasonic sensors. They're going to react in this loop to any obstacles that they detect. And here it's set at 4 inches. Now you'll notice you can adjust these to equal to, greater than, or less than. And let me suggest not using the equal to, because that might work 1 out of 30 times. The sensors, they go out of range constantly, and so trust me, use the greater than or less thans. Now in the future, if you have more advanced sensors, then equal to will be right on the money. But what's perfect, right? Okay, so if it detects, so we have the sensor 2 and 4 here, and So if it detects either one of the sensors less than 4 inches obstacle, I have it just going backwards and turning. So it's just going to keep doing that, and that's what this movement loop does. Now, let's get back to the color sensors over here. Now you'll see this broadcast color tile located right here. Now the way I have it set up, or had it set up, or have it set up here, is that it's going to use this navigation loop when it starts until it sees one of these colors. Then this broadcasts color tile located, okay? When that happens, that triggers this loop, okay? Now when that happens, it stops other stacks, which is that other navigation loop, okay, and runs this navigation loop. So now we have a new navigation loop, and this is how we were able to accomplish it, detecting the color tiles before attempting a shot. So it's another navigation loop. This time we have it set currently if the sensors, the left side sensor detects less than 5 inches, stop moving, broadcast found target. Okay, and then I put this in as a contingency in case it runs into or sees a black color. Then it will turn and then move straight until it comes within 5 inches. Okay, so that's what I had done here in case it doesn't do what it's supposed to do, and it doesn't always, because the sensors are glitchy. So so when it broadcasts found target, once this occurs, it jumps over to this new loop. Okay, now this is a kind of a targeting loop, I guess. So I have here, if sensor number 2, which is the left front sensor, is less than 4 inches, then I have it to kind of angle itself into a firing position. Now I would have loved to make this a lot more complex, but, well, not really a lot more, but a little bit more complex. That way it could better fine tuning, but the sensors aren't really capable of doing that. So we would, maybe if we had like laser sensors or something like that, then we could make the shot more accurate. So if that happens, it turns into a better position, broadcast fadeaway shot, which is that little extra piece I put in there with that when it drives backwards and then fires, because we were joking around about things that can be done. So I was like, okay, yeah, I'll throw that in there. And over here, it's basically the same thing, except for if the right hand side sensor detects less than 4 inches, it'll turn that way and then fade away shot. Okay, and then over here, just if let's say if it miraculously comes straight head on, okay, so we have an and. So if 2 is 4 inches and 4 is 4 inches, it's going to just go straight into the fadeaway shot without the move, and that's like, it's possible, right? Okay, so the fadeaway shot handoff goes over here. Now, I have figured out how to do multiple things at once, and the way to do that is to separate loops and have them operate at the same time. So it can be done. So here we go. We have the fadeaway shot. When I receive that, it broadcasts fire cannon, and then also slows down the movement speed and goes backwards. Okay, so that's the fadeaway. Now when it broadcasts fire cannon here, that jumps over to this loop and activates while this is still going on. So we have the motors A and D. A is another move motor, drive motor, and then D is the servo for the foot, right? So this is how I have the shot going. So that runs, and then I've measured everything through testing, so I know exactly what it takes for the shot. And if you look at the video where it's like showing the shooting action, you'll see that it's right on the money there. But this is how we did it. And like I said, this is pretty easy to just, you know, switch these little blocks around instead of copy and pasting. And it seems like it's just a little bit quicker, and you don't have to type a bunch of stuff out. A lot less copy and paste, and it does work. Now, if we had a little bit better tech, it would probably work a little bit better. But yeah, I guess moving forward with this sort of stuff, you know, you can get into like Arduino or, you know, other microcontrollers or even PLC programming, depending on which way you want to go. And that's where the big bucks are in manufacturing. Or, you know, you could be a botter, or you know, like me, kind of freelance. But this is what we did. So I hope you enjoyed the video, and we'll see you next time.